ladies and gentlemen, welcome back. Here we go again. Another periodic table drawn on the screen, and your eyes are rolling into the back of your head, but I don't care because it's fun. All right, ladies and gentlemen, so you need to go ahead and get it drawn. Notice I've got it color-coded. It would be nice if you would color-code yours as well, because we're, again, going to be looking at these regions of the periodic table, and we're going to break them down even further. And so the regions that we're going to be looking at today are the S, the P, and the D region. Notice I don't have that F region drawn down there, and so what we're going to do is we're going to start assigning those addresses to those electrons so we can start getting into exactly how and why elements react and act the way that they do. So an electron configuration, all it really is it's just going to show us energy level, sublevel, and how many electrons are in any particular location. All right, and so really they are electron configurations. They're used to show us locations of all the electrons in a particular atom or element. Okay, so notice I've got part of a Bohr's model drawn down here on the bottom of the screen. It's not complete, but you'll notice I've got the first four principal energy levels drawn. N equals 1, 2, 3, and 4. So the first thing that we're going to do is we'll get into exactly what and where these sublevels are found, because remember from the last lecture, sublevels, all they do is they just break down each energy level into different subcategories and sub-energy levels, right? Because think of an energy level as a building can have multiple floors, right? The energy levels are the same way. We can actually break them down into different levels inside of each energy level. So the first energy level will only have one floor, if you will. Only one floor, only one sublevel. It's only got the S. The next one we get to at principal energy level 2, it'll have both an S and a P, right? And so notice now the general trend here, we go up in energy level, we add a sublevel. When we get to N equals 3, guess what? We've got S, P, and D sublevels in the third energy level, and then you guessed it probably already, when we get to the fourth, we've got S, P, D, and F. And so this will be important when we start labeling inside of our periodic table. It's key to notice when an S shows up, when a P shows up, when a D shows up, and when an F shows up for the first time, because that'll tell us when we start adding those particular sublevels to the energy levels, and it'll make a difference of how we add. There's an exception here that you're going to have to catch, all right? Okay, so now we're going to go in and look. Remember, periods are energy levels. We're going to start adding in our sublevels. So the first thing we're going to do is we're going to say 1s right there for hydrogen and helium. And all I'm doing, it's in the first period. It's in the S region. Notice this guy, out of place. It actually fits there. That's why there's that gap over there when we're talking about electron configuration. So helium is actually in the 1s region. Okay, next thing we do is we go down to the second energy level, and we're in the 2s region, and then we're in the 2p region over here, right? The third one, we do 3s, and then we come over here and we do 3p. The fourth energy level, 4s, and then here's where your exception comes in. This is 3D. Notice the D showed up in that principal energy level 3, and so the first time we label an energy level for a D, it's in the fourth period. So the D's always trail by one energy level. The D's always trail by one energy level. The D's always trail by one energy level. So after 3D, we do to 4P, and then we've got 5S, 4D, 5P. Hopefully you're recognizing all I'm doing is notice the first P is actually second, right? And I'm just counting down, so 6S, and then let's do this. 5D, 6P, 7S, 6D, and then 7P. And I left the F's off because we're not really going to get into the F's in here. If you make it into PhD level chemistry, you'll start talking about F sublevels if you're in nuclear chemistry. We're going to leave those out, though, for simplicity's sake. Okay, so now, how do we rank them? Right? Because if they break them down, you know the S is not equal to the P because you have one floor in a building that's higher than the other, right? So we do have one of those sublevels that's a higher energy than the other. And so how do we read this, right? How do we read the periodic table? Well, we read it just like a book. The lowest energy level is 1s. The lowest energy level is 1s. The lowest energy level is 1s. And so if we're going to rank our sublevels, we're going to rank our sublevels in order of energy. and we're going to go low to high. All right, so we'll start with 1s. I just told you 1s is the lowest energy, and then we read a book. So with a book, you read to the end of a line, then you go back to the beginning of the next line, and you read over it. And so if you just follow the periodic table and read it like a book, it'll actually give you all of your energy levels and sublevels in the proper order. So after 1s, I go to 2s. Well, I still need to read to the end of the line here, so I do have to go all the way over here to 2p, and then I get to the end of 2p, and I'm going to jump down to the beginning of the next line, which is 3s, and then after 3s, you got it, I go to 3p, and I'm over here. I go back to the beginning, I'm 4s, and then I am 3d, and then I keep going. I'm going to come down here to the other side. After 3d, I would do 4p, and then after 4p, I would do 5s, and after 5s, I would do 4d, and after 4d, I would do 5p, and so on, so forth, etc., etc., etc. All right, and so what this does is it allows us to rank this, and then the really cool thing is that we're looking, the number of elements that the particular region is across is how many electrons fit there. So remember, this S region is 2 elements across, 2 electrons fit there. That's a maximum of 2 electrons. The 2p region, or the p region, 6 elements across. 6 elements, or 6 electrons fit there. The d region, 10 elements across. 10 electrons fit there. And so again, we're going to start placing these electrons, and we're actually going to use where they're at on the periodic table to tell where all of their electrons go. It's cool like that. So what I'm going to do is I'm going to do a couple of examples, and this is just an introductory stuff. There are some other things that we're going to do with electron configuration, but right now I just need you to get just a general location of where our electrons are. The other really important rule that I want you to get written down is that all of your sublevels will be full with the maximum number of electrons except for the last one. The last one is the only one right now that won't be full, or can't be full, or won't always be full. It'll be full sometimes, right? But the last energy level in sublevel is the only one that cannot be full. So a couple of examples of what we're talking about here. You'll see this. First element I'm going to do is helium, right? Helium is right here. This is helium. Notice it's in the 1s. I would put 1s, 2. It's 2 across in the 1s. It's the second element. And so I would put 1s, 2. The 1 there is your energy level. The s is your region. The 2, how many electrons are there? So you want to make sure you get that written down. Next example I'll do is carbon. Carbon is element number 6. It's about right here. I can't see that. It's about right there. That's where carbon's at. Notice it is actually 2 across in that P, and so I would start with 1s, right? Because I have to start reading here every time. After 1s, I would go to 2s, and then I would get into 2p. Well, carbon is actually, if you look at your periodic table, and hopefully you've got that out by now. If not, pause and get that thing out so you can see this. Carbon's the second element over in 2p. And so what we would do is just say, hey, it's got 2 electrons, and then everything before it has to be full. And S will always carry a maximum of 2 electrons. And so I just fill it up. The next one we'll take a look at is magnesium. So magnesium, where is magnesium at? Magnesium is element number 12. It's in the third. This is magnesium right there. And so again, where do you start? Well, you start with 1s, and then after 1s, where do you go? 2s, because again, we're just ranking these in order of energy. We have to fill the lower energy levels before we can place any electrons in the higher energy levels. So I go to 2s, and then I go to 2p, and after 2p, I'm in 3s, and that's where my element's at. Notice it's the second one over in 3s, so I would go 2. Well, I go back and fill up everything before it. Well, the P holds 6, the S holds 2, the S holds 2. And so that's my electron configuration. That tells me where, what energy levels, how many electrons are in the first energy level, how many electrons are in the second energy level, how many electrons are in the third energy level. It tells me where they are all at. All right, the last example I'm going to do with you is bromine. Bromine is actually in 4p. It's actually about right there. All right, and so again, get your periodic table out. Where does all this start at? It starts at 1s, and then it goes to 2s, and then it goes to 2p, and then it goes to 3s, and then it goes to 3p, and then it goes to 4s, and then it goes to 3d, and then it goes to 4p. That's where bromine's at, is in 4p. So I'm just reading the periodic table until I get to the energy level and sublevel or region of where my element is found. I'm going to count how many it is over. So you count in that p region, how many over is bromine? Well, it's the 5th element in that region. Right, so I'd have 4p5 as my end, and then everything else before it, ladies and gentlemen, it has to be full. You cannot, I mean, think of a glass of water. You can't fill the top of the water glass up before you fill the bottom, and everything goes to the bottom. Everything filters and funnels to these lower energy levels before it will fill those higher ones. And so that's why it's important to understand how to read this, all right? So now we'll go in and we'll put all the other ones. Well, remember, 10 can hold, or D can hold 10 electrons, S will hold 2, P will hold 6, S is 2, P is 6, S, right? And then there we got it. Now remember, the exponents are electrons. Bromine should have 35 electrons. So if you add up all the exponents here and we have a neutral bromine atom, you should have a total of 35 on those exponents, all right? So you can double check that. All right, that was quite a bit. That was fast and furious. If you have any questions, make sure you get them written down. We'll get them addressed in class, or you can come to tutorials and get that taken care of. And otherwise, I will see you there.